Hi guys, this is Hilmi, and today I want to show you how to test your lines. Let's say you have a repeater right here, and then say you're going down, you have a tapper, you have another tapper. Let's say this is a different floor, and that's a different floor, and then let's say you have an antenna right here, right? And then let's say you have another tapper here, and then you have another antenna, and then you have another antenna here, and then you have another tapper, antenna, another antenna, 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 right? So you are, let's say, here with your spectrum analyzer, right? And then let's say the signal is bad, right? You're receiving, I don't know, maybe 90 dBm. That's really bad coming under the antenna, right? That's not acceptable. So because it's bad, it could be this line, or it could be this line, or it could be this line, right? Because these lines have nothing to do with this antenna. So we're only looking at this line, and this line. So, for example, if you were here, right? If you had a spectrum analyzer here, and if this was bad, then you would be looking at either this line, this line, this line, or this line. This line has nothing to do with this antenna, and obviously this line has nothing to do with this antenna. I want you guys to understand this. So this is the concept. Let's say this line is bad. This antenna is bad, right? So we're going to have to test this one, this one, this one, and this one to find out which one it is bad. So I have a good way to test these. Okay, let's test this line. Okay, so let me clean the board. Okay, so I have a tapper here. It could be any tapper. And then I have this line, and I have an antenna. This going somewhere, this is going somewhere. It doesn't matter where they go. This is what I do. I disconnect that, right? So I have a connector, line, and I have the antenna. I disconnect that also. So I have a connector, line, connector. Here's what I do. And let's say roughly this is 100 feet. Okay? I put my signal generator right here. Signal generator. Right here. And I connect my signal generator to this with an adapter. So my signal generator is an SMA connector, SMA female connector, and then my cable is usually N male connector. So we need an SMA male to N female adapter, right, to connect these two. SMA male to N female adapter, right? You can get this adapter from Edgar. Edgar has some. Ben might have some too, so you guys can figure it out, and you connect it. So what you do is you pick a frequency. It doesn't matter what frequency you pick. For our purpose, I would like to pick 862 megahertz. And then for the power, I would like to be around 0 or 0.5 dBm. Okay. So we connected that and we're pushing 862 megahertz, and then we are pushing 0.5 dBm into this line. So how are we going to measure this other end, right? So we put our spectrum analyzer, which is the RF Explorer, but RF Explorer has signal generator and spectrum analyzer. So signal generator goes to one end and the spectrum analyzer goes to another end, right? This is our spectrum analyzer. Right. So our spectrum analyzer, just like our signal generator, has SMA female out, and our cable is obviously N male usually. So in this case, we need a SMA male to N female. However, we have to put some attenuators in between. We have several attenuators. Some of them Edgar has and some of them Ben has. Okay, you can ask those attenuators from them. You want to put two 15 dB attenuators back to back. So you have a 15 and you put another 15. They are, one end of these attenuators is N male and the other end of the attenuator is N female. So it'll go easily into this and then they can connect to each other, right? And then what you're going to get is N male goes to N female. Over here, it's going to have an N male, and female end of the second attenuator goes to here, and then you're going to have an N male here as well. The attenuator has that N male connection. So you will need an SMA male that screw into SMA female to N female that goes to the N male. So that's how you're going to get the connection. That's not a jumper, that's an adapter. SMA male to N female adapter that'll screw in. Okay, so what did we do? We put about 0 here, right? And then that power came here, and then we put additional 30 dB, 15 plus 15 is 30, attenuator, right? And then we put an adapter to connect here. Obviously, when we pick the 862 megahertz into our signal generator, we're going to program the spectrum analyzer to 862 as well. Okay, so then that's going to receive it. So what do we expect? If I'm hitting 0, okay, into this, I know at 100 feet, if my cable run is perfect, I will lose about 2 dB. So that 2 dB I'm going to lose. Let's say I will lose maybe half a dB or less in one connector and half a dB or less on the second connector. So let's just say half and half is 1, right? Half plus half is 1. So my total loss when I go in here, the cable, like connector, cable, and connector, half and half is 1. So 2 plus 3 is 3 dB total loss, right? 3 dB total loss right here. So what I expect is, I come in with 0, 0.5, doesn't matter. I will lose some on the adapter too, but like I said, very little, maybe half dB, right? So 0, and then half, 2, and half, that'll be 3. And then I put 15 plus 15 is 30. So about 33. So I should read negative 33 dBm at my spectrum analyzer, right? If my cable and connectors are perfect, right? When I send 0, right? I lose half, 2, because it's 100 feet. Another half, that is 3. Half, 2.5, 3, and plus 30, 33. So I should be seeing negative 33 at my spectrum analyzer. If I do, then my run is perfect. I can move on to the second line and test, right? But if I see 60 over here instead, that means my line is really bad. I have a kink, I have something, something. One person can do this. You can go in here, connect, and you can go in here, connect everything, and then you can figure out if this line is good or bad. You can test any line. You can test riser line, you can test donor line, you can test any line. I just wanted to talk about this so you guys can understand how we test these lines accurately. Thank you.